All right, questions 8 through 10. We're in part 2, unit 2.4, special right triangles and the geometric mean. So remember, to find the geometric mean of two numbers, you're going to multiply them together and take the square root. So the geometric mean of x and y would be the square root of x times y. So for number 8, we're going to do the geometric mean of 4 and 36. 4 times 36 is 144. The square root of 144 is 12. And you could get a negative there, but we're just going to accept the positive solution. All right, number 9. So same thing, we'll do 9 times 150. That's 1350. And I don't know that square root off the top of my head. No, it's because I got the wrong number. I'm sorry, it should be 6 times 150. I'm just making sure you're paying attention. So when we do that, we should get the square root of 900, which I do know that square. Square root, that's going to be 30. And then lastly, 8 and 18. So 8 times 18, we get 144 again. The square root of 144 is still 12. All right, so we should be good on the geometric mean. All right, questions 11 through 22, we want to use those special right triangle patterns. I know you can use a calculator on the final, but I don't know if you can use a calculator on this part of the SAT. And we know that this is a topic that we expect to see on the SAT. So for a 45, 45, 90 triangle, we know the legs could be represented by x, and the hypotenuse, I wrote that totally wrong because I was talking and writing at the same time, is x times the square root of 2. For a 30, 60, 90, you know what, I'm going to switch pens. Just having a lot of issues here this morning. It's Monday. 30, 60, 90, the short leg we can represent with x, the long leg x times the square root of 3, and the hypotenuse 2x. Okay, so now let's go through and figure these out. So in 11, I see it's marked that these sides are isosceles. So if it's an isosceles right triangle, it has to be a 45, 45, 90. So if one leg is 9, I know the other leg is 9, and the hypotenuse is 9 root 2. That one's pretty easy. 12, we're given the short leg of a 30, 60, 90. So I know I double it to get my hypotenuse, and I multiply it times the square root of 3 to get the long leg. All right, 13, we're given the hypotenuse of a 30, 60, 90. So half of that is going to be the short leg, and then the short leg, again, times the square root of 3 makes the long leg be. Number 14, I can tell that's isosceles and right, so 45, 45, 90 rules apply. So if this is 2 root 2 for the hypotenuse, if I divide 2 root 2 by the square root of 2, I just get 2 for the legs. So x and y are both 2 units long. And 15, 45, 45, 90, so I know again the legs are the same, so x is 6 root 2. And I know people get confused when we see a radical expression in the leg, but we still just multiply that by the square root of 2 to get y. So y is going to be equal to 6 root 2 times root 2. And in Algebra 1, you learned that you can multiply two numbers that are under the radical sign. So we can do root 2 times root 2 is going to be the square root of 4. And we know the square root of 4 is 2. So this becomes 6 times 2, which is just 12. All right, number 16, 30, 60, 90 again. We're given the long leg is 8 root 3. That's not so bad. Divide off the root 3 to get the short leg is 8. And then we know the hypotenuse is twice 8. So the hypotenuse is 16. Sorry, I had to adjust my camera for a second. All right, number 17, question 17. We've got again a 30, 60, 90 triangle. We're given the long leg is 16, and this is a harder problem. So if my long leg is 16, to get to my short leg, I need to divide that by the square root of 3. So 16 divided by the square root of 3. But you also learned in Algebra 1 that we don't like radical expressions in the denominator, so I can rationalize it by multiplying by the square root of 3 over the square root of 3. So this becomes 16 root 3 over 3. And since I keep hitting the camera. Since 16 is not divisible by 3, I can't really simplify that further. So I'm just going to write the expression as 16 root 3 over 3 for A. This is probably the hardest problem on here. Then to get C, the hypotenuse, we still just double the short leg. So if I were to multiply this number now by 2, remember as a fraction, that's just 2 over 1. And the only number on the top that would get multiplied by 2 is the 16. So you would have 32 root 3 over 3. And that's still not divisible by 3, so that's how we write our answer. That's a super tough problem. Oh, 18's not any easier. 18's a really similar problem again. We've got the long leg is 13. So A is going to be equal to 13 over the square root of 3. We'll go through the same steps to rationalize it. And we're just going to get 13 root 3 over 3. Because root 3 times root 3 is the square root of 9, or just 3. And then double that for C. So 26 root 3. It would help if I could make words today. 26 root 3 divided by 3. All right, 19. Easier, right? Because it's 45, 45, 90. Except no, it's not, because the hypotenuse is a whole number. But it's not that much harder. We know x and y are the same. So we only have to do one operation, or one series of operations. So we know that if this is the short leg times the square root of 2, I'm going to have to divide the hypotenuse by the square root of 2 to get x and y. So we get 18 divided by the square root of 2, which when we rationalize that, we get 18 times the square root of 2 over 2. And now I can simplify that because 18 is divisible by 2, so we get 9 root 2 for both values of x and y. One more row and then we're done with this page. Number 20, that is a square, and we are finding the diagonal. And we know the diagonal of a square is going to cut it into two congruent right triangles. Because a square is a rhombus and has 4 congruent sides, we know that they're isosceles right triangles. So this is a 45, 45, 90. I know x must be the same as the other leg, 19, and y is 19 root 2 because it's just the hypotenuse. 21, we are finding the height of that triangle and the length. We can assume that this entire triangle is an equilateral, equiangular triangle. When we drop that hypotenuse in, we have now two 30, 60, 90s. So if I consider the hypotenuse of the 30, 60, 90 is 46, I know the short leg is going to be half of that. So L is equal to 23. Then to find the height of that triangle, well, that's just the long leg of my 30, 60, 90 right triangle. So that's just going to be 23 times the square root of 3. And last problem. You could think of this as a trapezoid, but I think that would cause you some trouble. It's much easier to just think of this as a rectangle with a triangle attached to it. We are given that this entire length is 68, but we know up here this top length is 38. So I'm going to say from here to here is 38, which means from here to here must be 30. Let's see what else. We're trying to find x and y. So we have a 30, 60, 90 triangle here. If my long leg is 30, that means I have to divide it by the square root of 3 to get my short leg. So 30 divided by the square root of 3 becomes 30 root 3 divided by 3, or 10 root 3. So the short leg is 10 root 3. And since this corresponds with a rectangle, we know x is also 10 root 3. Then to get to the hypotenuse y, we double that, 20 root 3. So y is 20 root 3. All right, we are done with page 2.